We will begin with a panel discussion on quantum secure communications. Speaking today will be Yohei Matsueda, General Manager for Digital Solution Mitsubishi Corporation London branch. Stefan Natsu, Head of Product, Amazon Bracket, AWS, and Teik Guan Tan, CEO of pQCee. Moderating today will be Steve Suarez, founder and CEO of HorizonX Consulting.
Thank you very much. And they've told me that we are the last panel before we have drinks. So we're going to make this very interesting. If not, we're going to go ahead and get the drinks to be brought in here so we can just start early. What do you guys think? Yeah, good. Excellent. So yes, Steve Suarez. I'm the CEO of HorizonX. Just started the company less than a year ago. Before I had this, I was the global head of innovation at HSBC, and very interested in this topic. So when they asked me to come from London to speak on this, I raised my hand and was ready to speak. And I was very lucky to get a good crew of people to speak with me, even if some of them just came about 2 minutes ago. But Yohei, let's start with you. Can you introduce yourself and a little bit about your background?
Yeah, thanks, Steve. So, yeah, firstly, thanks for having me for this exciting event. So, I'm very glad to be in the part of this panel. So, thanks, Steve and team. So, firstly, my name is Yohei Matsueda, the General Manager of London branch of Mitsubishi Corporation. So, basically, I'm covering the new business development and the research of the new technologies in London branch, covering the cutting-edge technologies such as AI, digital, deep tech, like quantum technologies. So, but I want to touch upon a little bit about the Mitsubishi itself. So, Mitsubishi is a very conglomerate company in Japan, one of the largest one in Japanese market called the Sogo Shosha in Japanese market. So we have been doing the trading and the investment business in here, Japan, and also the multiple countries. So the London, the UK is one of our portfolio countries all over the world. So some Japanese people said we covering the ramen, from ramen to rockets. So that's showing the area for the coverage, a broader area for covering we are doing the business. So yeah, I'm quite happy to be here, and yeah, thanks for having me.
That sounds very interesting. I'm going to use that from ramen to rockets. Sounds very delicious. Actually, one thing I found out in Mitsubishi is that their logo is a propeller because their history comes from shipping. Maybe you guys already knew that, but it was kind of a surprise to me. And once I saw the logo, it was good. Stefan, let's move on to you, and maybe you can introduce yourself and talk about this company. I don't think anybody's ever heard of AWS.
It's a new one. Thanks again. Thanks, Steve, for the invitation. Really happy to be here, and it's a great conference so far. So yeah, it's been really nice visiting and talking to customers and so on. So so my name is Stefan. I run the product team for Amazon Bracket. So Amazon Bracket is basically AWS's Amazon Web Services, essentially collection of kind of 200 plus different web services, right? So like if you look at storage, compute, across AI and machine learning and containers and serverless and so on. And Amazon Bracket is sort of our quantum computing service. So we give customers access to quantum computers, which is they allow customers to research and develop applications in quantum computing via the cloud. And so today we provide access to multiple sort of third-party quantum hardware from multiple providers such as IonQ, Rigetti, QEra, and so on, many of whom and pretty much all of whom are here. And really the kind of mission of Bracket essentially is to allow customers to explore and experiment and build expertise and ultimately develop applications, right? So for example, one thing that's sort of relevant to this topic is some algorithms like Shor's algorithm, right, which I'm sure we're going to talk about is really about but there's really not that many quantum algorithms today that are known quantum algorithms where there is truly this exponential speed up, right? The reason why we're all here is because there's promise of this technology to provide exponential speed up for sort of commercial applications and do things that would take classical computers many years or millennia to do and do that in a matter of hours or minutes. And so discovering those new applications is really an active area of research. And so on Amazon Bracket, our mission is to sort of accelerate that research. So I'm responsible for our product roadmap, our integrations with multiple hardware providers, our kind of overall kind of long-term service vision and strategy. And I've been with AWS for 5 years. I started out in the machine learning space. When I joined, I was actually on the solutions architect, so the sales side, the pre-sales side. And when I was doing that, I said, it's great. Like, you get to talk to a lot of customers, but you don't get to build anything. So I said, okay, let me, move to the product side. And 2.5 years ago, I basically moved to, build out kind of the product team for Bracket. But my background is in quantum physics and condensed matter physics.
Yeah. Excellent. So Yohei, you're from London, and you're based in?
I'm in New York.
New York. Excellent. And one thing about Stefan before we move on, he told me, he whispered in my ear, and he said that please ask the audience to make some really hard questions for Stefan. If you can make some equations or math, he loves math questions. So I told him I'll try. So start working out some really hard questions for Stefan. He told me he really wanted to do some math today for you to show off his skills. Is that right?
But after the drinks.
After the drinks. Excellent. Teik, how you doing? Everything good?
I'm good. Thanks.
Teik is a nice player, because I saw Teik walking across the street, and I was like, hey, I need a fourth person for my panel. Would you join me? And he said yes, and the nice people were nice to put his picture up really quick. I'm not kidding around. Teik just realized he was going to be on my panel about 10 minutes ago.
Yes.
But Teik happens to be a pQCee quantum communication expert. So I won't give him any hard questions, because we're going to keep that for Stefan. Teik, can you introduce yourself? Tell us where you're from as well.
Sure. So hi everyone, and thanks Steve for having me on board and bearing with me. You guys could have just enjoyed the three of them, but I'm Teik Guan, based in Singapore. So I'm representing the Asia side. Although anyway, I run a startup called pQCee. We are a very young startup. We're only about 1.5 years old. Before this, I've always been in the startup business. I've done a multi-factor authentication company, which I sold off. Retired for a while, midlife crisis. Didn't know what else better to do. I went back to do my PhD in quantum cryptography. I graduated in 2022, and therefore I'm here now. So, yeah.
Excellent. We're happy that you're on this panel, because I think you're the only one that has a PhD in quantum cryptography. Here. Okay, I was gonna go in a certain order, but now that we're sitting this way, I'm gonna change the order up. So I hope you guys are okay with that. Yohei, I'm gonna start with you. Tell us about how you got into quantum. Why is Mitsubishi interested in quantum computing, and how did you get into quantum?
Yeah, Steve, thanks. So in short, the I or we, I'm not sure. Personally, I believe that quantum is a promising technology, and might change the world, may change the world in the near future, after completion of the development, computing particularly. So probably, as you might know, that computing machine can solve lots of problems which we cannot solve at this moment. So that's some kind of reason we now focusing on that kind of researching and investing, also investigating some of the areas we can jump into. But in terms of my journey, so when I first met with you was the last November. I think we discussed about the Q day over sushi in a Japanese restaurant in London. So basically, Steve is a friend of my boss, one of the friends of my boss. So so you and he met at the short-term program for the MBA in Harvard. So that's a starting point for us to start kind of discussion about the quantum in London office. So with Steve. So actually for me, so before coming to London, I was in Australia, and then in covering kind of the mining businesses for the digitalization point of view. So I was in charge of the optimization for the mining operation, like a whole range of the mining, digging, or dispatching the trucks or something. So in Australia. And then first day I met with the quantum annealing actually. So I saw the article, one of the civil engineering company in Japan was tried the test trial for the quantum annealing for the track the dispatching or routing for the dumping or something.
Yeah.
So that's the first time I saw the quantum in terms of that world. So, but after the discussion with Steve, we discussed when the Q day is coming. So you might know the Q day is the day they break the encryption method for the existing ones, so by the conventional techniques. So that would be 2030 or 2040, not sure where, but sooner or later that day will be coming. So we have to start something to adapt that new technology. So that's a starting point for me. And then after such kind of discussion, so we also, firstly, I'm a little bit a new joiner for the quantum area. So basically, my background is IT and digital. So as I said there before, jumping the quantum world, so I was in optimization, the AI, mathematical way. Of course, that's conventional techniques. But so regarding the quantum, so it's the kind of the 8 months or less than 1 year, to be honest. So still learning process. But again, after having a chat about the Q day, so I started deep learning or deep diving into the quantum world, catching up the computing or timelines for the quantum sensing and the encryptions. The kind of the quantum communications and the computing, and hopefully there are potential timelines to be realized in the future. And then, that's the current state for me.
Yeah.
Sorry.
No. That's okay. No. That's okay. I mean, it's kind of funny. He talks about his background going from mining to quantum, which is it's a radical change. But I could tell you the journey you're going through, a lot of people will be going through, right? Because nobody's born knowing quantum. And I think it's such an important part, especially quantum security and everything that's going on. So I think your journey is going to be a lot of people's journeys. And I think it's great that Mitsubishi is allowing you to invest time to look at this. I know today, just kind of, we were at Mitsubishi this morning, and we had a session on Q Day to understand how quantum will impact communications. And so this is how important that they're taking it. And so let me just go ahead and jump into some of this stuff on the quantum side. And Stefan or Teik, we can kind of go to you guys. We mentioned Shor's algorithm. Can you give the audience just a very high level of what Shor's algorithm is and why it's important on the technology side? And then I'll get into some of the solutions. I won't mention.
He'll explain the nice one. I'll put everyone to sleep.
Excellent.
Yeah, I mean, just sort of very quickly, essentially, actually, the algorithm was, developed by Peter Shor, professor at MIT in the mid 90s, and it was actually a number factorization algorithm, right? So it's an algorithm that uses quantum computers to essentially develop the prime factors of any integer, right? Which is, essentially a very, very hard problem for classical computers, and really kind of the foundations of RSA-based cryptography, which is, the encryption standard, pretty much the encryption standard for, all of our data that's encrypted, today worldwide, right? So essentially what, Peter Shor was able to demonstrate when he, wrote this algorithm was that, if one had a quantum computer, then by basically leveraging his algorithm, one could achieve, essentially exponential speed up over solving this prime factorization problem over classical computers, right? So it was known to be a very hard problem for a classical computer, could in principle be, and I guess an easy problem for a quantum computer. Now, the challenge, of course, is that, in order to actually solve kind of like real prime factors of very large numbers, you essentially need a fault-tolerant quantum computer with very, very high levels of, qubit fidelity, because, ultimately these algorithms are very, very deep, so they require executing essentially kind of trillions of gate operations. And also you need, thousands and thousands of actual qubits themselves, right? And whereas if you look at where quantum computers are today, they can execute about a few hundred gate operations, maybe a few thousand gate operations, and we have on tens of qubits, right? So we are really kind of orders of magnitude away from kind of when that will become a reality. But one of the reasons why companies like AWS, companies like Mitsubishi and others are really investing in this technology now is that it is a disruptive technology, and so as a result, we need to sort of prepare for that future, when it might arrive, right? And because it's disruptive, we don't really know when that inflection point will happen, but what we do know is why this conference is even happening here. And when I joined Bracket, this conference was only in Silicon Valley, and now it's in it's in Paris and it's in Tokyo and so on, is because the hardware is advancing so rapidly, the software is advancing so rapidly, that those incremental changes are kind of every single year marching us closer and closer and closer to when we think that inflection point will happen, right? So and so I think that's kind of
and it is getting sooner. So I know that governments are now putting out executive orders. I know in the U.S. there's an executive order that if you want to deal or sell to the U.S. government, you have to be pQCee compliant, which Teik, I'm going to let you kind of explain what pQCee is, and we'll get into QKD. But these are things that are happening now. So everybody talks about quantum and when we're ready and stuff like that. This is the security side of this has a lot of people's attention, and especially people in the cyberspace. I think, unfortunately, what happened, a lot of people that couldn't travel here, and the whole thing with CrowdStrike wasn't that, but we could easily see things like that happening in the space if this technology isn't addressed. So, Teik, let's go ahead and just jump in. Let's kind of describe some of the solutions, the pQCee and QKD, to the audience.
I shall try to explain it in simpler terms, right? So if you're hearing all these pQCee and QKD, it starts to get confusing. Let's put it in simple ways. QKD, or quantum key distribution, is the physics way to solve the quantum threat, right? So how do you want to mitigate the quantum risk? With physics, you use QKD. If you want to use math to mitigate the quantum threat, then we go into pQCee, or post-quantum cryptography. Even within post-quantum cryptography, there are, again, different branches of how they want to do it. But maybe I'll just add on a bit more to what Stefan said, right? He said that Shor's algorithm can do bad stuff. So one of the strategies within pQCee is, let's try to design an algorithm that's not vulnerable to Shor. That's a simple thing, right? So that's one of the strategies where you go design an algorithm that's not vulnerable to Shor. And if you go study a bit deeper into it, and this will have a bit of math, you realize that RSA or Diffie-Hellman, all these are commutative or associative in nature. That means like A plus B and B plus A are, you can switch around. And if you can make it non-associative, non-commutative, means A times B plus C, it breaks that ability for Shor's algorithm to actually attack that cryptography. And that's the basis of where you hear things like lattice-based cryptography, which is what the National Institute of Standards and Technologies is trying to standardize. So they're using lattice-based cryptography with learning with error in order to have an algorithm that they are very sure is safe against Shor's algorithm. So that's one strategy for it. The other strategy is to take away math totally from the cryptography side. And that goes into like hash-based cryptography, where you no longer have mathematical structures inside there, no algebraic structures. And with this, chances are you could only use Grover's algorithm, which is a quadratic speedup, and therefore less vulnerable to Shor. So that's really the study of pQCee, where you either go into the safe against Shor or only vulnerable to Grover. So these are the two strategies where you work on as you design your pQCee algorithms.
Yeah, the funny thing is, it depends who I talk to will tell you what the solution is. If I'm talking to a physicist, they're going to say QKD. Don't forget about the other stuff. Those mathematicians don't know anything. And obviously the mathematicians say, no, pQCee. But it is kind of a battle. And so the good news is that it's not mutually exclusive. You could look at both of these technologies. And I can tell you, in my past life, that was part of my job, is there's something nearer, which is kind of the pQCee and how do you approach this. So you could look at the pQCee, but you could also look at QKD. And if we really want to get really interested, we can talk about quantum internet. But we'll keep that for the appetizer. I mean, for the desserts. We won't kind of talk about that. Yohei, tell us about what industries are looking at this right now. So who's out ahead, and what are they doing in this quantum secure, looking to secure their communications?
Yeah, as far as I understand, so the simply speaking, the industry who is taking care of some the handling the sensitive data, so such as the finance, defense, or telecommunications, I think. Yeah. So from Mitsubishi point of view, so we are trying to find out some of the good use cases and figure out how we can start this kind of the pQCee adapting. So under our Mitsubishi portfolio. So because the focusing on that such kind of industry. So because given the kind of timelines for the Q day or some this day, so probably let's think about the life cycle of the hardwares or some the product life cycle, like automotives or semiconductors. Potentially we have to start now because if it's the 5 years the life cycle or some 10 years, we should start now because we cannot change after the release of this kind of release product. Or if you have some the multiple IT systems or some bunch of data, so probably we need to assess when we should start or this kind of the pQCee adaptation. So yeah, so that is also to some view of myself.
No, I think that's an excellent point because people are like, oh, well, a quantum computer won't be strong enough, so we don't have to worry about it. But there is that point of this harvest now and decrypt later. And I'm going to poll the audience. How many people in the audience have heard about harvest now and decrypt later? Okay, so I'm going to ask the audience now to answer. No, I'm just kidding. No, I'm not going to. The harvest, not a lot of you put your hands up. So, Stefan, are you okay? You want to speak to that one, or you were going to save the hard questions for you? That one's an easy one, or is that one? I can give it a shot. Okay, and yeah, go ahead. Let's just.
I think essentially the idea sort of is that even though quantum computers today are not powerful enough to crack these codes and so on, the belief is that they will be in the future. And so essentially, what one could do is sort of just gather the data right for now, store that data somewhere in some database, right? And then once these computers do in fact be powerful, because it's ultimately an exponential speed up, right? You can essentially now just trove through this entire data set and start to decrypt and get access to all of customers basically sensitive information and PII information and so on. So that's really kind of the threat that a lot of companies are sort of trying to protect themselves.
And the funny thing is, people say, well, that'll be in 10 years. So if you're not worried about it, think about 10 years ago. So let's go back to 2014. Imagine if we had access to all of your phones and we could look at all your data. I tell you what, why don't we do an exercise? Everybody pull out your phones. Pull out your phones. Pull out your phones. All right, unlock your phones. Go ahead and unlock your phones. All right. Now pass your phone to the person next to you. Why aren't you guys passing your phones? No, I see somebody. Okay. Yeah. That's if any of you guys kind of got that instant sense of fear, that's the sense that what happens with this technology, that imagine all your data is now available to anybody in the world that can be able to crack this. And so that's why it's very important that we're able to be able to look at that. So, all right, so let's talk about the limitations. Let's talk about QKD and the limitations of QKD. Is that something you can talk about?
Yes, of course. So just to add on to what Stefan mentioned about this whole harvest now, decrypt later, and some of the work there. So the experience I have when speaking to some of the CISOs in Singapore, it's not that they are not worried about the harvest now, decrypt later. They tell me that in 10 years' time, I'm probably already fired from my job, so it's not my problem anymore. So that's a different problem to solve, right? So they are aware, but unfortunately, the life cycle of a CISO is less than 10 years, and that is another problem we have to solve. Okay. Yeah.
Wow, that is an issue. Yeah.
Yes. So when we talk about QKD, it is about being able to exchange a key. So being able to have the same key, a secret key, that is being transmitted to two different communicating parties so that both of them will have that same secret key in order to perform the necessary encryption, right? So that's QKD in general. So you have 2 points and two parties being able to use the same key in order to perform the secure communication. What's great about it? It's great. I mean, we know that just having a secret key and using like AES-256, we are already quantum safe. And that's many of the organizations, some of the larger ones like MasterCard has openly come out and said that that's what they like. Okay, the downside of it, and there are 2 points. One is that it is talking about two different parties. So it's about what we call data in motion, communicating between Alice and Bob. But if Alice wants to store data for herself, then QKD is not exactly the best solution for it because it's about storing data for yourself, right? So that's called data at rest or data in storage. Unfortunately, QKD doesn't really fit well in that. The second thing, which I believe will be resolved over time, is that the cost of QKD, and this is where the pQCee guys come in a lot, they criticize that QKD is expensive, infrastructure, and all that stuff. So that's probably something that will be resolved in the longer term, and I'm sure Mitsubishi will have a solution for that. But at this point of time, unfortunately, QKD solutions are of a sizable magnitude in cost, higher than pQCee solutions.
But even delivery, right? Because QKD, if you're doing it through fiber, has the no replicating, no cloning problem, so that every 1,000 kilometers it loses its signal.
There are now quantum repeaters coming in place, so there are new protocols and all that.
But they're also looking at satellites and trying to do that. And I know that there's kind of denial of service or cloud cover and some of that. So I guess, yeah, definitely find it interesting. I see we got 13 minutes left. Don't forget, get your hard questions for Stefan. He really wants to make sure he can answer those hard questions for you. Okay, excellent. So we talked about QKD. We talked about pQCee. There's companies like Apple and Zoom that are not waiting. They're going ahead and deploying that out. You know, what do they see that nobody else is seeing? Why are they moving so quickly? Anybody?
Well, it's great that they've done it, and what they have done is they've used dilithium 768, which is one of the NIST standards that's being standardized right now. So watch out in summer of this year, the NIST has already publicly announced that they will come up with the new pQCee standards.
But NIST has been saying that for a while. Yeah, well, I know they're saying it. I'm hoping they'll say it because it's going to be a very big thing. But you're right. I think
well, we'll see. But anyway, the draft standards are out, and if you want to implement it like what Apple and Zoom have done, they have implemented using dilithium 768 for their messaging app itself. I think that's a great marketing move. I think it's what we are seeing, at least even within Singapore itself. The Central Bank of Singapore, the Monetary Authority of Singapore, has also said it's not so much of what's the final solution, because we really don't know what the final solution is, but it's about getting your people ready, as in that they are comfortable in working with post-quantum algorithms, being able to update algorithms on the fly. And that value is what you want within your organization today, right? I was mentioning that in 2 years' time, the most valuable line in your CV is 2 years of experience in post-quantum cryptography, because it's something money cannot buy. You have to actually start working on it. And the only way you can start working on it is to run some pilots. And therefore, Apple, Zoom, not so much for their customers, but really for themselves in starting this project.
I love it. I'm going to go ahead and update my CV right now. So that's good. Stefan, I'm going to ask you the last question, and then we're going to open it up to everybody. What can the audience do to educate themselves? In other words, what education opportunities are out there? This is all new understanding between the fight and the mathematicians and the the quantum physicists and all this other stuff. You got any thoughts for the audience before they ask you really hard questions?
I'll share a couple of things we're doing at Amazon first. I just want to quickly add to what Teik was saying is that I think it's really about that readiness is one of the reasons why at AWS, so we launched the quantum computing service at AWS back in 2019. Amazon for a very long time was thinking, when should we invest in quantum? And every year, it's sort of the decision was, well, we don't think the technology is quite there. It's not quite ready. And then in 2019, we finally flipped the switch. And the reason was that, we saw that, Amazon as a company has a history of investing very, very long-term technology. So for example, we were doing AI/ML in our fulfillment centers in the early 2000s. And so similarly, kind of having that 10, 20-year horizon, essentially the company said it was time to sort of start getting our customers ready to understand all aspects of this technology and how it's going to impact their lives. And so in 2020, we launched Bracket. We were in GA with Bracket. But in 2021, we basically announced a Center for Quantum Networking. And really the goals behind that center were sort of threefold, right? So, one was to essentially, ultimately when we start having fault-tolerant quantum computers, we're going to need quantum networks to actually to have those quantum computers talk to one another and exchange quantum information. So that was the first one. The second one was to actually look at things like pQCee and QKD and so on, because our customers we need to get them ready, because our customers are basically putting their most sensitive data in the cloud. And so therefore, us having a footprint and thinking about this technology on their behalf is essentially existential, for AWS. And then the third part was, how do we actually get customers and how do we sort of help train that next generation? So, in 2021, we announced a collaboration with Harvard to basically start, educating that next generation of students and kind of helping build out that quantum workforce. And so what can customers do, today, at least on Amazon, is they can, engage with us, kind of run small POCs. We have a quantum networking team that can, educate them around the various aspects of pQCee, QKD, run small pilots, which we've been doing with a number of our customers as well with our professional services team. But also if people just want to learn about this, I think you've got a course that,
Yes,
they can go.
Thank you for that. I'll go ahead and make sure I pay. Yes, yeah, you get a, yeah, I'm in the process of rolling out a course at MIT, specifically on this. We'll be launching in September. If you guys want a discount code, HorizonX 10, but we can talk about that later. But yes, I'm actually, and I'm glad that Harvard's doing something. At MIT, we're going to be rolling out a quantum computing for corporate executives and government leaders, and the security part of that is very key. So you guys are one of the first to hear it. Watch this space in September. With that, we have 7 minutes and 36 seconds. So let's go ahead and see if anybody has any good questions for Stefan. Math questions. Comments? Algebra, calculus. No, any questions around this lattice space? Anything? Nothing? No. All right. No questions from the audience. They want to go out and have some drinks already. So, tell us from technology. We talked pQCee, we talked QKD. Are there any things we didn't talk about that this audience should hear about?
Well, there are things that QKD and pQCee cannot solve.
Tell us about that.
Right. So, the unfortunate